Hey guys, welcome back to Code 4. Today we'll be seeing some logic gates questions from the recent past papers. So before I begin, I know November series exams are up right now, so good luck for those writing them. Also, if you're new to Code 4, this channel is all about educative stuff. So don't forget to subscribe and hit that bell icon for instant notifications and make sure you share our channel. Okay, now let's dive right in.
Hey guys, welcome back to Introducing the Given Data. We dive into vulnerabilities from IGCSE theory, that is security and ethics.
This question is from Feb March 2022, paper 1 2. So here they've given us a set of inputs and asked to tick the boxes wherever the output would be 1. So to make it simpler, let's tackle this question column wise. Okay? So first we have the AND gate. So as we know, both inputs have to be 1 for the output to be 1. So only the top box gets ticked. Second, we have the OR gate, which outputs 1 if either of the inputs are 1. So both the top and bottom boxes should be ticked, but not the middle one because it does not have the digit 1. Then we have NAND and NOR. The thing that makes NAND and NOR really easy is that they are the exact opposites of AND and OR gates. So if we have ticked the AND gate, such as in the first one, we shouldn't tick the NAND and vice versa. So here the NAND and NOR are completely empty. But here in the second row, we have not ticked AND or OR, so we have to tick both of these. Here we have ticked OR but not AND, so we have to put a tick here. Lastly, we have the XOR, which can be a little tricky. So I have the truth table for you in this side. In XOR, only one input should have the value 1 for the output to be 1. So only the bottom box gets ticked. Okay, now moving on, the next question asks us to draw a logic circuit. So first, let's underline what's in the bracket because that's what we have to do first. So in the first bracket, we have A XOR B, and in the second bracket, we have B or not C. So first, let's do what's asked in the first bracket. So we have to draw the XOR gate, which is very similar to the OR gate between A and B. Okay, I know my drawings aren't perfect, but please deal with it. Next, they've asked for B or not C. So here, first we have to do not C. Okay, and then we have to add a wire from B and then draw an OR gate here. Now both of these wires have to add up into an AND gate. And that's it. So on to the next paper. This question is from May-June 2022, paper 1-2. Looks like this is also a logic circuit. So let's just use the same method we used for the previous question. So first, let's underline what's in the brackets. So first let's draw an OR gate for inputs A and B. Next, next we can draw an XOR gate for B and C, but it should be followed by a NOT gate because it's in the brackets. For now, let's take the output at the top as Y and the output at the bottom one as Z. So now we have to draw an AND gate with inputs Y and Z. After this, we have and C over here. So you have to draw one last AND gate, and then we're done. Okay, so moving on, section or sub question B asks us to complete the truth table for that logic statement. So, as I've written below, the tip to solve the truth table easily is to solve it in the same order in which we drew the circuit. So, yeah, I've written down the order in which we solved it above, and I've also drawn arrows to make it easier to show which value should be carried over where. I've also drawn the truth table for XOR because that is a pretty tricky one. Okay, so let's try this. First, we have A or B. So, either value has to be 1 for the output to be 1. Next, we have B XOR C, which means only one value should be 1. So, next, we have to carry forward the previous column and do the not of it. So we have to write the exact opposite of it. So next, we have to carry forward this column and also the first column and then and both. So last but not least, we have to and this column with C. So this is our final value. Next, this question is from May-June 2022, paper 1-3. So, AND, OR, and XOR are three examples of logic gates. Four statements are given about these logic gates. Tick to show which statements apply to each logic gate. Some statements may apply to more than one logic gate. Okay, so the first statement, if both outputs are 0, if both inputs are 0, the output is also 0. So this applies to all three gates. Next, if both inputs are different, the output is 1. So this does not apply to the AND gate, but it applies to the other two gates. If both inputs are 1, the output is 1. This applies to the and OR gate, but not to the XOR gate. Next, if both inputs are the same, the output is always 0. This applies only to the XOR gate. Next, NOT, AND, OR, and XOR are all examples of logic gates. State the name of two other logic gates and complete a truth table for each. So the two gates that we're missing here are NAND gate and NOR gate. So NAND gate is the exact opposite of the AND gate. So the truth table should be filled accordingly. Same goes for the NOR gate, which is the exact opposite of the OR gate. So if any of the values are 1, it should give an output of 0. And that's it. So that was the last question for this video. Thank you for watching till the end. Hope this was useful.